LTC 2022 on Research Data Management and Stewardship, Building Blocks for Open Science. We begin today with our first session on open science, frameworks, policies, and open data. This session, we begin with a keynote by a distinguished professor, that is Professor Gautam Menon, who is Professor of Physics and Biology at the Ashoka University. He's also a professor at the Institute of Mathematical Sciences, Chennai, and he's also an adjunct professor at TIFR, Mumbai. Welcome to LTC 22, Professor.
Thank you so much.
We are honored and privileged to have you give the keynote on this topic, which is dear to us and I'm sure dear to you as well. Over to you, Professor.
Thank you so much. And thank you to the organizers of LTC 2022 for this opportunity to tell you a little bit about what I'm thinking of at the moment. So I want to survey this whole question of open science and open data from a sort of personal perspective. And I should emphasize that I'm not an expert on all of these topics that you have listed, open science frameworks, policies, and open data. But I can say that I've been thinking about the importance of data, especially public health data in a pandemic, and the need to be transparent about how we understand, how we approach this data, and about the availability of data, especially from government sources. So my own point of view will be mainly from the point of view of a practicing scientist who interfaces with government on data, but is outside the government system and therefore faces different sorts of barriers from someone who's inside the government system, for example, who works directly with government, such as the Indian Council for Medical Research. But another part of this is also my involvement in thinking about data availability, especially public health data, as a citizen of this country. And all of us have the dual roles of being professionals in what we do, whether we're library scientists, whether we are practicing biologists or epidemiologists, or just regular people. Then what is the relationship that we must have with our governments regarding the data that, in a sense, we pay for in terms of the taxes that we pay, the support that we provide our elected representatives. So let me say a few things about open science in general, just to set the stage. I imagine that these terms will be familiar to most of you, and you will have heard of these in the last couple of days. But open science is a movement to make the results of scholarly research more accessible, including all the components that go into it, the code that goes into analyzing certain types of data, the data itself, as well as research papers that are written that summarize the nature of the work across a longish period. So this is, of course, an area that many governments across the world have been interested in. And the UNESCO recommendation on open science, which is subtitled Making Science More Accessible, Inclusive, and Equitable for the Benefit of All, was adopted by the 41st session of the UNESCO General Conference in November 2021. So fairly recent, although these ideas have been around for a fair amount of time. So the recommendation on open science looks upon science as a common good, something that we create together for the benefit of us all. And the second part of it, which is where transnational and international collaborations enter, international understanding must enter, is in the narrowing of science, technology, and innovation and digital gaps that exist between and within countries and within regions. For example, India is fairly digitally advanced compared to many countries, for example, in Southern Africa, in Sub-Saharan Africa. These are large divides. And this is where we should investigate whether the experience of one country or one region or one grouping can help ameliorate or even out the gaps that exist regarding data, as well as digital accessibility. At a broad level, if you could ask, what does open science or open data imply? That means the free availability of research data, data that is collected, research processes, how was the data collected, how do we analyze it, that enable the reuse of the data, the redistribution of the data, as well as the ability to reproduce the research itself and the underlying data methods. So when we talk about what is the implications of open science, really we're talking about all of these together. It's not just the data that should be available, but the methods that went into the analysis of the data and all of the metadata surrounding the descriptions surrounding just the bare data itself, which can be equally or even more important than just the data. And the idea here is to increase the rigor, the accountability and reproducibility of the research. And again, this is very important at a time when our research outputs and the research enterprise as a whole across the world is really exploding in terms of participation, in terms of the number of scientists working in these areas across the world, the reproducibility becomes a genuine issue. Ethics in publishing becomes a genuine issue. The ethics regarding, surrounding the acquisition of data becomes an additional issue. So the idea is to make these processes transparent so that they can be criticized and critiqued and evaluated, and good best practices imported from areas which have them. Beyond these, there's also an ethical imperative. And this is something that I want to expand upon in the slides, in later slides. And these underlie the principles of inclusion, fairness, and equity. And it's these ethical principles that should also apply to the way we treat and understand and distribute our data. And part of this is making research more open to participation, irrespective of where you're from, irrespective of your background, your culture, etc. Making it open to review or refutation, introducing corrective or self-correction mechanisms into the evaluation of research, the improvement of research, and the ability to reuse research. So you don't have to reinvent the wheel every time for the world to benefit. And that's the ethical imperative here, is what are the concerns of the world at large, and where is it that we can do the best for the most people. When you look at the practical parts of it, and this refers to the frameworks of open data, there's a variety of practices that come under this general rubric. One is open access to publications, open research data, research availability of data, the use of open source software that is not that so that people all around the world can use this and are not restricted by price barriers to very specific and very expensive types of software. So the encouragement of open source software and tools is certainly an important part of this. Workflows, how exactly the work was done to make that transparent. Citizen science, involvement of the public in the generation of scientific data and the generation of scientific knowledge. Open educational resources so that we do not privilege one class of people who can pay more for an education than others. So making these resources available openly. And other ways of improving or changing the nature of the way by which we evaluate for promotions, for prizes, for awards, etc., as well as the evaluation of papers by the public, by the scientific community at large, including open peer review, so that the asymmetries regarding involved in citation circles where a small group of people circulate their papers among each other in order to be reviewed and ensure that all of them appear. These are now removed because everyone can comment upon the papers prior to publication. So that was the description of all of the good side of open data and why we should be thinking about open data and open science. So one can ask, where are the problems with this and what's wrong? The first problem, of course, is gatekeeping by scholarly journals, by expensive journals, as it turns out. The second is perverse incentive structures that favor closed rather than open research. The third is the lack of appreciation of the value of open science and data. And I want to expand on each of these points separately before I get to what I want to talk about, which is health data and accessibility. The lack of appropriate intervention by governments when they can. And finally, a lack of a critical mass of researchers or a research community that's willing to change existing structures. And I see that as also being very important and very crucial to this. So gatekeeping by scholarly journals, of course, you will all know, as people involved in libraries, that the business of publishing science is among the most lucrative in the world. And here's an example from 2015 of the profit margins of companies, for example, a standard automobile company, a mining company, a search engine like Google, etc., or even a premium computing company like Apple. And look at the two below, Springer and Selvia, whose industry is scholarly publishing, and look at the profit margins that they're making. And this is 2015. Now we can look at 2020 and look at where these numbers have changed. And you can see that the Elsevier scientific publishing unit is now at 38%. And Elsevier's profit margins exceeded those of Apple, Google, Facebook, and Zoom. And these are the companies that we think of nominally as being extremely successful companies internationally, extremely successful multinationals. Perverse incentive structures. And over here, it's structures that really the community builds in, and to think of science as a competition and not a collaboration. There are certain incentives, for example, public recognition, career progression, financial incentives in the cases of some countries to publish in so-called high-impact journals such as Science and Nature. The pressure to patent and to commercialize the fruits of research is a new pressure. It didn't exist about 40 to 50 years ago. And there the question of if you publish, if you make data available, if you make science open, then there arises the question of prior art, which makes commercializing or patenting the results of that research somewhat more difficult. Much of Western science, and increasingly science across the world, including in China and Japan, the Far East, etc., in Europe, is really like an engine with vast armies of PhD students and postdocs feeding into this enterprise. Many of them will not get academic employment, but they will have to leave after a certain number of years and look for other options. But the whole business of science, and I use the word business in a very carefully calibrated way, relies on sustaining this engine of productivity and output. And whether in the long term, this is really beneficial to science, another type of question that doesn't really enter what we're talking about here. The pressure to maintain lines of funding by describing exclusivity, by the ability to dominate a field by not sharing the data that you have amassed on your own. That again is another type of pressure that looks upon science really as a competition and not a collaboration. And finally, hiding data in order to mask unethical behavior, to make the fact that you made up data increasingly an important problem. And we see, for example, in examples of these websites that maintain records of faked or falsified data, typically in biology, of gels where the shifts are essentially made up and cut and pasted from other gels. Questions of authorship. So if you keep the more vague you keep the sources of the data, the more you can hide the importance of giving credit to those who are authors on a particular manuscript. The third point that I want to make here is a lack of appreciation of the value of open science in data. And over here, I want to emphasize the fact that we do not train our students in the art of sharing data, the mechanisms of sharing data, and what one must do in order to make it available. So here, this is addressed by essentially better training. How do you describe what are suitable mechanisms for sharing? How do you use, for example, markup languages that can systematize data in a way that everyone across the world can share it? There is a fixed way, a fixed structure that describes that sharing. The uniform formats for programs, certainly programming, everyone uses different programming languages, although slowly some communities are shifting very largely to using one or two Python or R for certain very specific statistical programs. But the availability of multiple programs, the multiple programming languages makes the sharing altogether far more difficult. Often, of course, labs are in collaboration, labs are in competition with each other. And in fact, in some cases, it can approach as difficult a situation as principal investigators or PIs requiring that a person in one lab does not contact or speak to a person in another lab. So again, this goes back to science as the increasing tendency to view science as a competition and not as a collaboration. Let me talk about the lack of appropriate intervention by governments and the research community here. And that is, the governments can intervene by providing a stronger support to society journals and nonprofits over here, and altering the incentives that they have to publish. For example, if evaluation systems here, if the government insists that evaluation systems are not tied to, for example, journal impact factors or the numbers of papers that you publish, just simply altering these incentives to publish can also change the nature of the landscape under which data is available and open to be shared. We don't provide enough credit for people who make data public, who construct large public databases that are completely transparent in the way that data is allowed to be accessed. The mandating availability of data generated using public funds. That's again an important point in which governments can actually step in by saying that anything that is generated using public funds must be publicly available in a certain format, which can be translated across different domains, as well as make it easier for anyone to actually use it. Typically, governments allow for large consortium agreements, for example, for the use of a whole suite of journals. This is a partial fix. It's not a true fix to the problem because it just reduces the rates, but the philosophy that allows journals to gatekeep is still maintained. There's a broad, I want to return to this point a little later, that there's a broad principle that material that is generated using public funds should be available for public access. And for me, this is really the moral question that underlies the nature of open data and the nature of open science. And finally, the use of preprints, mandating the use of preprints as a prior condition to a later scholarly publication, so that this data is available publicly and the analysis is available publicly in advance. From the point of view of a scientific community, for example, for which I belong, the lack of a critical mass that is pushing for change is certainly obvious. And one example, of course, is just scientists refusing to referee for journals that are overpriced or that are unfair in terms of their data access. And if enough scientists want to change, the whole system can itself change. So far, apart from fairly select communities, for example, the computer science community or some parts of the physics community, there's no indication that this is really very broadly the case. But however, times are changing. And my own experience is that anyone who has ever sat in a library committee discussion will have felt the same sense of outrage at the pricing of these journals. And the fact that the author now increasingly does all of the work, pretty much most of the work, the journals would do earlier. When I submit a paper to PLOS, I've already formatted it. I put it in a language in which LaTeX, in which the journal can understand it. I've made all of the micro adjustments that the journal might require. So it's practically camera ready by the time it actually reaches the journal or goes to a referee at that point. So at this stage, when authors are doing more and more work that earlier traditionally the journals were doing, it's not clear where the value add to the journal actually comes in and why these prices should be as high as they actually are. So what we need on behalf of communities, such as the ones to which I belong, the scientific communities, is concerted and spontaneous action. I said that I'm not an expert on many of these areas, although I have been tracking them, I've been interested in them. I want to talk a little bit more about my personal experience from thinking about the COVID-19 pandemic and lessons that the COVID-19 pandemic holds for open science. And the one important lesson that it holds, and one that I've been writing and speaking about, is the nature of data availability. Much of the data that is required is really fairly simple data on cases on a daily basis, accurately collected data, cases on deaths. How are these computed? How are they calculated? That's also important metadata, descriptors of the data, but also clinical information about the seriousness and the severity of the cases that an infection of COVID-19 infection leads to. It's interesting to notice or to remind you that the most trusted source of COVID-19 data in India, and in fact across the world, was a crowdsourced, volunteer-driven, anonymous effort. It was initially, this website shut down on October of last year, and its work was taken over by other websites. But COVID19india.org was very crucial and critical in providing the information that was used worldwide in understanding the trajectory of COVID-19 cases in India. In fact, the whole question of data was so important to some of us that we wrote a letter, a large group of scientists wrote a letter to the government regarding data availability. And here's a newspaper description of that, which the scientists appealed to the Prime Minister to make COVID data public. This happened at the end of April of last year, of 2021. And here we describe the need for making data available outside the government system for analysis by people who had no stake in the matter, no stake in making the numbers appear better or worse than they actually were, but who wanted to understand this in order to prevent or to be able to predict or prevent or intervene in any future increase of cases. This was covered fairly extensively. So even Nature wrote an article here about the nature of about how governments ought to respond to scientists who were pointing out difficulties in the availability of data. And a little later, Professor Gagandeep Kang and I wrote an editorial about how even prior to Omicron, so at the time when Omicron was just increasing, how the lack of availability of data was like flying blind into a storm. That's the analogy that we use, that we have no way of understanding where one ought to go. We're just moving straight into the storm. And one way of clarifying that way would actually to make the data available, that is with the government. Can I say that the situation has improved in the roughly 1 year, in fact, almost exactly 1 year since we wrote that letter? And the answer is no, it's a little better. There doesn't seem to be any particular incentive for government to make data available, or in fact, its methods, its own predictions for the course of the pandemic. And we heard recently from a person high in government who said that we had models, we were able to make this available to people in government across India to understand what is going to happen in the coming weeks, etc., etc. But it was pointed out to this person that the models were not transparent. It was not possible for someone to be able to critique, for someone outside to be able to critique that. So this is not a good situation, because the only useful models are those models which can be stripped threadbare, whose assumptions can be analyzed, whose predictions can be broken down. Only then can it be useful. And something that is closed in a black box is really of no use to anybody. So there are severe downsides to this, and it's important to realize that expertise in this area, and especially to make this point to government, that all the expertise is not vested in the government, especially academic expertise does not necessarily belong to government. And this is an important reason why data should be open, so that many, many more eyes can look at the data, can evaluate the quality of the data, can comment upon it, can look at the methods that are used to analyze that data and generate public policy prediction. Because the policy that government makes is something that affects all of us as citizens. What could change in the future? And certainly a larger role for preprints and pre and post publication commentary on the part of scientists is something that could certainly change things for the better. The preprint culture started with physicists. In fact, the first time I heard of preprints was from the Los Alamos archive. And I heard about this in the early 90s as a summer student in a summer school somewhere else, where one of the people who started it, Paul Ginsberg, asked for about 10 minutes to describe this new revolution, this new approach to making data and information public, which was just to put preprints on a public server where anyone could access it. And the nature of preprints and the accessibility of preprints has, I think, been very crucial in really leveling the playing field for scientists across the world. Biologists have been late adopters, physicists, mathematicians, computer scientists, to some extent social scientists on a different type of archive, the AcSIR and other types of archives. But making preprints and a commitment to open science and open data should potentially be a part of the review process, for example, for awards, for promotions, etc. One of the important questions should be, to what extent has your own work helped and participated in this effort to make data and methods available to the larger group of scientists, as well as potentially to the public who funds this research. There are broader questions than just these. So these are sort of practical implementations on the part of what scientists could do, encourage preprints, include these as part of their evaluations, etc. But a larger question is, what is the government's responsibility to its citizens? And can we use public data for the public good? So again, here, this comes back to the fact of the fact that data and scientific effort that is collected or supported by taxpayer money, which is the money that you and I pay to support our governments, to support what our governments do, it should be accessible to the public. And of course, with health data, there are certain concerns concerning privacy. So we must make sure that the information that you make available cannot be traced back to the individual. But nevertheless, these are ethical sort of minefields or ethical gray zones, which we should understand and evaluate and come to a consensus regarding what sorts of data can be available, what level of aggregation is suitable, that we can put things together and then get from there to information that can be used by a public health system, by people outside, without compromising on privacy. So as I said, the question can a government or should a government at all try to conceal data, try to make data unavailable if that data has been collected using public means? So for me, very broadly, and I'm now drawing this as my last slide, the requirement for open science and open data is a moral and ethical question. And there are questions here, even in the sort of longish title that you had, there are questions with differences between principle and implementation. Implementation can come later, provided we decide on the principle. What I have been saying consistently is that one should have to make a case to hide or conceal data, and especially any data that is collected using public money. Default should be to share that data, and it should be hard enough. There should be a certain barrier to concealment of that data. And you can imagine that there are certain national security imperatives, for example, that might say that, look, this data should not be made public, but should be made, but should be only available to a select group within government or to government itself and not to the general public, because there are dangers, there's a distinct downside to making that data available. Right now, the situation is that the government could, in principle, shut down availability of any data at all, whatever it chooses to do. But the default is that that ought to be made public. The default should be that concealing any part of it should be the far harder task than just exposing all of it. The availability of data also enables interesting sanity checks on it. So does the data make sense or not? Are there problems with the collection of the data? As long as you don't have multiple eyes, multiple skeptical eyes looking at the data who don't have a vested interest in the outcomes of the analysis of that data, it's possible to inquire into the quality of that data itself. And I say this specifically with respect to public health data. Public health data in India is a fairly complicated question because there are certainly questions about the quality of the data, the nature, the way the data has been collected. But if you have many eyes looking at it together, then it's possible to ensure that the data quality is actually good. So the economist would say, how do we ensure the right sorts of incentives to do this, the right sort of incentives for open science and for open data? And as you can see, this is a fairly large and complicated question. There are things that government can do, there are things that institutions can do, there are things that individuals can do, there are things that students can do. But overall, this, as I said, is a moral and ethical question of, in order for our country, for the world, for the citizens of the world to prosper, it's important that intellectual knowledge base that we have managed to construct over the last many centuries in which science has become an important part of our lives. And the collection of data has become more and more central to the way we decide our policy based on evidence. That the need for open science and open data really now begins to intersect moral and ethical questions. And that the simplest question is, what is collected using public money should not be concealed. So let me just stop at that point. And thank you very much for your patience. As I said, I'm not an expert in this area. And my interest really has been in understanding the nature of of public health data and to ask what is it that we lose by making that data available to the larger public and what is it that we gain. And for me, that the calculus is very clear. We actually gain far more by having many eyes looking at the data as we would have during the COVID-19 pandemic. This is a view that is shared by many scientists who wrote that letter together. And this is an area which I think is a sort of paradigm, an example for the way we ought to be thinking about data and its availability. Thank you very much for your patience.
Let me take this opportunity to thank you and also for giving us not just a keynote, but I would say setting the tone for the entire conference, because you covered the entire gamut of issues from that of the challenges, or I would say the sensitive issue of how the scientific enterprise is set up, right from the bottom up of the PhD students, postdoctoral students who are feeding into that entire scientific enterprise, and from that point of view to the psychology and the economics of open data, and deep dive into the coronavirus data problems. And in fact, I must confess here, I started following Professor Menon and his passion for open data through his Twitter account, because I started looking at when 2 years back when COVID hit, I was looking at who in India is doing this kind of work and passionate about it. So thank you so much for your knowledge, expertise, as well as your passion for open science, open data, and the various issues. As he rightly said, one of the issues that brought open data into this is also the COVID. As they say, every crisis accelerates also some of the developments. Just like the reproducibility problem in psychology, which was primarily to begin with in psychology, pushed the need for the discussion towards open data. Today, coronavirus is also pushing us all towards how do we make this data, as he said, sanity checks to government data to everything. Thank you so much, Professor.
Yeah, Dr. Menon.
Yes.
Yeah. Good morning, very good morning. And this is Vishwanath from DRTC, Indian Statistical Institute. And so this is more than a question, actually, just to, I think, add that to your point that whether how much we should gain or how much we should lose. So, and you very clearly said that, yes, I think, as you said that, you see it more like a gain than the other side. And I do agree, because I just want to share here that we also, worked on COVID-19 data, and basically very contextual. That's what I thought to share my idea. So, we actually very much thankful to the Karnataka government, because they were making the data available, basically the tracing data, which is, very rare. And as per my experience goes, it is only the Karnataka government who made the initial level, like starting from 24th of March 2020 to 7th of July 2021. The data, they made it available, and we actually repurposed the data. We basically used the knowledge graph to to show that tracing that how the COVID-19 actually spread across Karnataka. We built a huge graph. Actually, that's a kind of huge case that shows that the repurposing of the data. And also I see that what you said, that actually it gives us more transparent way to look at the data. So this is what, just to vote you that, yes, I think we should gain. And this is my, like you are all in the, in that position, that where I think we should actually appeal to the government to make such data more available, because nowadays it's very difficult to get that clinical data or even the contact tracing data. None of them are actually available, except the, case data like, active cases, death and all, which is also good to have that. But I think that the most crucial, that where we are also working on the genome sequencing data, so that we can, trace out, so that, this, the particular type of, variants, right? So we are working on that. The main problem for us is that actually the data. So we don't have access to the data, but we are developing the model. So here, maybe what you said, maybe I don't know that how to, proceed, at least for India, to make this data available. Thank you very much.
Thank you for that comment. Thank you.
Thank you, Datta. I'm a Kannadiga, proud Kannadiga too. I am happy to hear that Karnataka was the first state to share this data. So now let us move in view of the paucity of time and to stick to the schedule. Now I would like to invite Dr. Jagdish Arora, who is the anchor for this panel discussion, to come over. And also I would like to invite all the panelists to come over to the dais, please.
Thank you, Shalini. So participants, we already have a gist of what goes into data, what is data management. And in fact, the two workshop that was delivered yesterday, you are already aware as to what goes into data, how it is to be managed, how it is to be curated, and other things that goes about the data. Now, if we're talking of open science, we now already understand what is the outline of open science, what are the different facets that we need to deal with. So basically, there are 6 facets, or they're also called school of thoughts, which include open science infrastructure, collaborative creation of knowledge, open access, open data and open source, citizen science and science blogging, open science of policies, open science policies, and open science framework. So we have 3 experts panelists with us, including Dr. Robin Rice, who delivered a workshop yesterday. Dr. Robin Rice is data librarian head of research data support information services at University of Edinburgh. We have Dr. Pragya Chaube. She is senior project associate, DST Center for Policy Research, Indian Institute of Science. And the third panelist we have is available online, Dr. Vidyadhar Y. Mudkavi. He is distinguished emeritus professor of Academy of Science, Scientific and Innovation Research, that is CSIR University. The 4th Paradigm Institute is one of the new CSIR institution. So we have 3 panelists, and they'll be talking on various aspects of open science. So to begin with, I would invite Professor Robin Rice. She'll be talking about University of Edinburgh RDM policy and open science roadmap and services. So you'll be going to hear something practically what is happening in a university as far as open science policy is concerned. So Dr. Robin Rice, please.
So in looking at the UNESCO policy recommendations, I'm going to focus on a university's contribution to the open science agenda through 3 policies actually, but I'll focus mostly on the research data management policy. Last year, we did 2 consultations at the same time for policy development at the University of Edinburgh. One was for new publications and copyright policy that had gotten to be about 10 years out of date. And the other was for the research data management policy, which had also gotten to be about 10 years out of date, coincidentally. But, and so we ended up with 2 quite forward-looking policies. And I was obviously more involved, being a data person, I was more involved with the data one, but the main points about the publications policy that I just wanted to point out is that I think the innovation is that, you know, we have Plan S over in Europe, which is putting quite a lot of push towards open access and sort of getting rid of the hybrid model that that the journals like to use for open access. Some people call it double dipping because they charge for the journal subscription and they charge for the also to make your article open access, the fee. So the University of Edinburgh new publications and copyright policy states that the academics can have the copyright of their works as employees of the university, but the payback for that is that they mustn't give it exclusive license to the publishers. So there's a model license. In fact, all the publishers have just been told outright by the university lawyers that that our researchers will retain the copyright, and they will create an open access version using the green method in the open access repository. So it gets around a lot of things, and the researcher doesn't even have to be entirely aware of the policy for it to happen. We just sort of take control and put a copy in the repository to make it available, and we won't pay the fees. So that seems to be working pretty well, and other UK universities are looking at that policy closely to see if they can follow in suit. But I'm not an expert on open access, so that was all I was going to say about that one. The other thing we're doing is open research roadmap, because we're part of the League of European Research Universities. And in that sense, we're following their open research strategy template, and we have it up on the website as the publications policy is also. And there's my folder. And so I was just going to tell you a little bit about what's in that strategy. Yeah, I meant to set the scene at the beginning that the UNESCO recommendations on open science as part of developing an enabling policy environment for open science. Under the letter D, they say encouraging research performing institutions, particularly those in receipt of public funds, to implement policies and strategies for open science. So that's the context of my remarks. And the open research roadmap covers, and we call it open research at our university to be more inclusive of humanities and the sort of softer sciences and the arts, so that it includes everyone. So it's this equivalent, open science or open research. And so we say that you're doing open research, you're doing research in an open way if you are following at least two of the following attributes: open access publication, open research data, open source software and code, open notebooks, open infrastructure, or pre-registration of studies. And so that LERU, League of European Research Universities template has asks questions about what you're doing, what the university is doing about cultural change. And we've kind of rated ourselves largely we've done a red, amber, green, how we're doing. And that's kind of rated as amber because we're doing a lot of outreach, but culture is hard to change. And we're leading this from the library. So it's, we need the academics to lead the change. And the future of scholarly publishing, we've rated that for ourselves as green because we have good infrastructure for the repositories. And fair data, findable, accessible, interoperable, reusable data is also largely green because we have the Edinburgh data share data repository and some other services under the research data service rubric to help people make their data feel. And we do actually have a lot of take up within the university of using that repository and the infrastructures. And the other one is about infrastructure or fitting in with the European Open Science Cloud, which is also largely green, although it's early days to fit in with the European Open Science Cloud, but we have some good infrastructure. Education and skills is rated kind of green to amber because while we have a lot of training, it's a very large university and there's more that could be done, and there's gaps in what we train people in. And recognition and rewards is another one that's kind of amber to red. So that's much harder to change, and that involves HR kind of things and things that are out with the library's control. And finally, next generation metrics, which we've got in kind of an amber category. We are a signatory to DORA, the Declaration on Research Assessment. And so that recognizes the need to improve the ways in which the outputs of scholarly research are evaluated. And citizen science is the last one, and that's kind of largely unmarked because we need to understand more about what sort of citizen science activities are going on within the university. We're not entirely sure from the library point of view. And now I'll just say some things about the research data management policy, which was first issued in 2011. We think it was the kind of the first one of its kind in the UK. And so there were sort of eyes on looking at what the update would be, because a lot of UK universities copied the basic principles of the first one. And so we stuck with the same principles, but we kind of fleshed it out and made it a lot more, I would say, more grounded in the other policies of the university, such as information security policy, data protection policy, also the publications policy. So it's sort of gotten to a more mature state. And the new policy adds clarity about the university's expectations of researchers, both staff and students. It adds important concepts such as making data fair and grounding concepts in other key university commitments and policies, such as research integrity, as I said, data protection and information security. And software code, which is so important for research reproducibility, is included explicitly. And that was by request of some of our academic stakeholders. So we have some good champions at University of Edinburgh that on the academic side that help keep us at the forefront. And we've added more definitions to things, references to some of the service components that can help researchers, like DMP Online, which is a tool for creating data management plans, data share, as I mentioned, the data repository. And in terms of some of the key messages, one is about responsibilities and the responsibility of the principal investigator. They retain the accountability. They're in charge of the research, and they're also in charge of their research data management. They can delegate that responsibility, but they're still accountable for the research integrity and the research data management. And students should adhere to the policy in collecting their own data. But when they're not working with data on behalf of a principal investigator or PI, individual students are the data owner and data controller of their own work. And also on the responsibility side, the university is responsible for raising awareness of good practice, provision of useful platforms, guidance and services. It's very clear, the new policy, that data management plans are required and what's involved in that. And particularly trying to get the researchers to understand to include costs for research data management in their grant, because the UK funders now, a lot of the all of the major UK funders and a lot of the other funders will allow costs for research data management, and it doesn't go against the competitiveness of your grant. So we need to have some cost recovery from the funded research in order to keep our services going. Although we do provide quite a few services for free at point of use. Things like big data and sensitive data require extra services and extra costs. And then, as I said, the new concept of fair data sharing, the old policy referred to open data, but as we know, not all data can be shared without some more nuanced things like data access agreements, restricted access. So the whole concept of fair is included. And for PIs to use data repositories, whether those are the ones provided by the university or external ones, and also to lodge software code in appropriate places like GitLab or GitHub. And finally, to consider the rights in research data is the last key point. So researchers need to consider the rights of human subjects, but also citizen scientists and the public to have access to their data, as well as the external collaborators. And when open access to data sets is not legal or ethical, such as sensitive data, information governance and restrictions on access and use must be applied as necessary. And we point to the university's research office, which has templates for data use agreements. And some future work is to partner with them to streamline that and make it very easy to just sort of take an agreement off the shelf and apply it to your data so that people can do this much more as a matter of course. And finally, this was in the original policy also, but the same idea as the publications policy, where exclusive rights to reuse or publish the research data must not be passed to commercial publishers. Thank you.
Thank you, Professor Robin. Professor Robin, in her speech, mentioned that she surveyed all the existing RDM services and framework and then developed their own. She mentioned about the components of the RDM and open science policy. She mentioned as to how people can, how and who can access the data. She mentioned that it's not that it's completely freely available to everyone. There are restrictions to data depending on the kind of data that you're hosting. And another very important thing she mentioned was that there are open science champions in the university who help people to adapt to open science and encourage faculty to come up with open science, adopt the open science platforms. So thank you, Dr. Robin, for sharing your views with us and your practical experience. Now we invite the second panelist, Dr. Pragya Chaube. She is Senior Project Associate, DST Center for Policy Research, Indian Institute of Science, Bangalore. In fact, I wrote to her as professor and she promptly came and I'm not professor, so I have some more year to go. Of course, she is very young. I did not see her physically when I started the communication. So she'll be talking about open research data practices that are happening in India and of course abroad. So I invite her to please speak to the
Thank you, Dr. Jagdish. You have been very kind to me. So firstly, I would like to tell everyone that it is an amazing privilege to be here and sharing this stage with these amazing, very experienced people. So thank you to the organizers for having me here. And yes, I would also like to put a disclaimer that I am not an expert in open science, but I am actually more of an enthusiast, and I would be coming from that side of the thing. So yes, I may be a bit young and inexperienced, but I'm still a bit old-fashioned in some ways. So I would like to begin with a quotation, a very cliched one. Excuse me, I'll be taking a look at my notes in between. So the quote is, "If I have seen further, it is by standing on the shoulders of giants." And it is a quotation that I know everyone in this room must be familiar with. It is by Sir Isaac Newton in a letter to a fellow scientist, Robert Hooke. And this quotation basically encompasses the essence of open science. It basically says everything. So when we are talking about geniuses like Sir Isaac Newton, okay, the person, he must be such a genius. He must have come with laws of motions and gravity all by himself. But this hardly ever happens in real life. Even he was standing on shoulders of somebody. And this is exactly how creativity and innovation works. Where no matter how bizarre any idea is, it comes from somewhere. And this is exactly how science also works. It is incremental. And we all know this. I mean to say, we all know this. That is why we have been publishing our results to disseminate that knowledge to the scientific community. And this is a practice that we have been doing since the 17th century, since philosophical transactions of Royal Society published their journal. They were not the first ones, but they were the first ones that were built up around the idea of openness, that science needs to have this free exchange of ideas to grow. But many years later, we are still here. We are still discussing science needs to be open. And the reason this change came is actually because in the 1960s and 70s, something happened that actually turned the entire idea of openness in science on its head. And that thing was basically when commercial publishers came into this domain of scientific publishing. And when we talk about it, this privatization of publicly funded knowledge, this entire thing is like a Pandora's box. There are so many elements to it. And thing is, when we actually talk about this basic aspect, we are actually trying to focus on one single thing, which is basically academic publishing. But there are so many other elements to it. I mean, what exactly is academic publishing? What our scientists are actually mostly publishing? We are mostly publishing significant, statistically significant results, which is basically a very minuscule part of what we do. I mean, to say it is actually a very good part of what we do, but still it does not encapsulate what we do as scientists. Science basically is built on data. So what as scientists we do on most part is basically collect, generate, analyze, publish, and reuse that data. And this is something that has been missing from this entire conversation since long, but like very recently it has been coming back, that how we need to make this data also open. And this is exactly what open research data is. So UNESCO framework that Professor Menon had spoken about before, they basically say that any data that underpins scientific results, and it is publicly accessible to everybody, is open research data. It could be raw data, it could be processed data, it could be digital, analog, it could be numbers, it could be text, it could be a media file, it could be codes, it could be workflows. But basically, it should be human and machine readable and should adhere to the FAIR principles. Now, thing is, like, we all know that we need this data out in the public domain for reuse, and no, reuse is not the only value to it. It's required for openness, transparency, reproducibility, and there are multiple other benefits of this. For example, publications that actually have open research data, they actually get more citations, there are more collaborations. So there are multiple benefits to it. Yet there is a certain barrier, there are certain barriers to it. So for example, a lot of people actually still try to publish their data through supplementary information in academic publishing, which basically is a barrier in itself. Because when we look at the data now, like the kind of data that we are generating, it's high throughput data in most of these studies. And this kind of data that you cannot host in an academic publication. And it's not just about the amount of data, it's also the format of data and whether that data is properly annotated. Like there are hordes of technical issues with that. And it's not just that, there are also cultural reluctance to share this kind of data. And this cultural reluctance comes obviously because of various reasons. Firstly, scientists are, unsure whether they will get the credit. So basically, there have been multitude of reasons where this open research data practices have taken, back a step. So to address all these problems, multiple initiatives have been taken. I'm going to talk about one of those initiatives, and it was called COP Committee, and it was set up by Center for Open Science. And they had a meeting in Virginia in 2014. and they basically proposed guidelines to the journals that how they can actually incentivize open science practices. And they give about 8 standards that these journals should abide by. And these standards including data transparency, whether the authors are actually putting their data in trusted repositories, or analytical transparency, whether they are putting their codes in public domain for check in these data repositories. So this is one of such initiatives that was taken. But the result of these initiatives was that a lot of international journals adopted this policy that they mandate that if you are actually publishing with them, you have to put their data, you have to put your data in public repositories, and you have to provide the DOI to the publishers. And this obviously is a very important step, because over the years, what it has done in the international community, especially in when we're talking about our Western counterparts, it has initiated this culture of open research data sharing practices in these domains. So I was told very recently, at least in this morning, that there are more than 2,000 open data repositories, and there are only 65 in India. And this number actually does not tell us anything. We do not know about its usage, who's using it, or how they are using it. But it actually points us towards something. So of these over 2,000 public data repositories, majority of them are concentrated in the US and the Europe. So there is basically part of the planet which is basically investing in developing open research infrastructure, open research data sharing infrastructure, and we are not in that place. So basically we have yet to catch up, and there is this definite gap that we need to fill. So my colleague, Dr. Momita Kole at CSIR IISc, we started this journey to understand what is happening with open research data sharing in India. And the reason for that is, according to NSF, we are the third most publication producing country. So obviously we are doing a lot of research. We are producing a lot of data. We are generating a lot of data. But then what are we doing with it? Where are we putting that data? So we did this interview with IISc faculty, people who are at different stages at their career, who are from across various STEM fields. And we started asking them about their own their views on open science practices, how they have adopted open science practices, and how they're doing their research data management, and how do they publish. And the idea was to capture this diversity across different STEM fields, and across the awareness across different career stages. And also, basically, we were trying to understand whether an infrastructural change is required, and infrastructural incentive is required. So right now we are at a very preliminary stage in our study, but there are a few findings that I thought would be interesting to the audience here. And first one is obviously the most obvious one, that yes, there is a cultural thing to this open research data sharing. And by the cultural, I mean there are fields which have actually matured when it comes to such practices, like biology. And but then there are fields which I still need a lot of catching up to do. And I don't even want to say fields like biology, chemistry, physics, because even within niche research areas, there are discrepancies. For example, even in biology, people who are dealing with omics data, they are more open towards open research data practices in comparison to, let's say, ecologists. So there are these very specific kind of variations that we see across different fields. And it's not only just about the amount of data they are producing, or the format of data they're producing. There are also kind of restrictions to what can be used for reproducibility. So when we are actually making blanket statements that all the raw data, or all the open research data should go into public domain, it actually can be very counterproductive, because there are fields where they are producing about data in the magnitude of TBs, but like the actual data that is required for reproducibility is actually much smaller. So these are the kind of things that we actually looked at. And apart from that, there was a very definite requirement for infrastructure. So we were talking to IISc faculties, and at the cost of sounding elitist, this is the institute that gets the most attention, that gets a lot of funding. And yet we could hear people talking about how infrastructure does not support long-term management for data archiving. So basically we need that kind of infrastructural support. And not just that, we also need capacity building, something that Professor Menon also spoke about. We need capacity building for people who can actually do data management and data archiving for long term. We need to develop that kind of a strength. And the third finding was basically people wanted more governance on their data. So yes, there was issues about data governance. They wanted more control over embargo policies and how they are sharing their data, who they are sharing their data with. So and the fourth and the last one was, yes, people are actually very scared of data spoofing. This is actually reluctance that has impeded open research data sharing in the country. Or I'm saying at least in IISc. So what these people need is basically incentivization. And these incentivization can come much like international journals. They can come from national journals. Our Indian journals have not really caught up to that trend where they actually require these authors to submit their data. Oh, sorry. Yeah. Well, I hope you were able to hear what I was saying. Sorry. So yeah, so I was at this point, so these people need incentivization from the journals, but most importantly, an incentivization step is required from the funding agencies, because the funding agencies are the one who are actually setting the culture or research culture in the country. And if the incentivization comes from the funding agencies, they will have an academic incentive to adopt open science policies, which is actually missing at the moment. So these were like all the major findings that we have had, and this is just the phase 1 of this study. And we know this is the major limitation is that it is from IISc, like just focused within IISc, and it is a very elite institution. But we actually would like to go and trickle down to other institutes as well and see what are the challenges that they are facing, because that would be different for different institutions, especially for state universities. That would be a very different ballgame. So this is something that we are planning to do, and yeah, and hopefully we'll do it sometime soon. So yeah, with this I will end. Thank you.
Thanks a lot, Pragya. Pragya spoke about life cycle of data, how it is to be processed, how the data is generated, experimented, interpreted, published, and to be reused. And this, she thinks that reusing data is something that is missing in the chain that we are talking about. She talked about raw data. The raw data cannot be published because it does not make sense unless it is annotated, unless it is labeled, unless it is made ready to use by others. And she talked about the top committee where they came out with standard about 8 standards that journal must follow for publishing the data, which includes depositing your data into standard repositories. She mentioned there are about 2,000 data repositories across the world, and there are only 65 in India. And of course, you don't know how active and how much are they used. Are the people putting their data in it? That also is a very doubtful case. She talked about the survey that she has conducted involving scientists in IISc, and she found that there is cultural blockage
for data sharing. There are deterrents for data sharing, which includes data scooping. There are issues regarding infrastructure. The scientists are worried, all right, I might share my data, but then who's going to archive it? Who's going to cure it? And how it is to be used? So those policies are missing, even in institutions like IISc Bangalore. We need capacity building, obviously, expertise on data management and data archiving. And finally, incentivization for data is what she spoke about. I would just like to mention here that, the quotes that you've shared, that if I have seen something or if I have learned something, it is by standing on the shoulders of giants. In fact, we have a lot of library science school students here, and the citations, when we learn about citation, it is the first quote that comes. That, when you cite a person, basically you've picked up from him. And citation, very interestingly, the concept of citation came from the lawsuits. In the lawsuits, you cite the previous suits. And with there, that concept came. And now, of course, citation is a big practice. And in way back in 1960s, when Garfield invented citations and came up with Science Citation Index, within 10 years, they predicted that who would be Nobel laureates in next 4 to 5 years to come. He predicted about 50 scientists, at least 10 to 12 of them finally got the Nobel Prize. In fact, there's a very interesting study where Garfield said why I was not able to predict Hargobind Khurana. He said that time they used to index only the first author, and Hargobind Khurana was always the last author. Because of the practices in biological sciences, the senior most author would be the last author. So very interesting studies are there in this context. But thank you, Pragya, for sharing your thoughtful views. Now, the last panelist is Professor Vidyadhar Mudkavi, who would be coming online with us. He is Distinguished Emeritus Professor of Academy of Scientific and Innovation Research, CSIR University. And Professor, he'll be speaking on open access, open data, and open source. So we look forward to hearing to Dr. Vidyadhar, please.
Thank you. Am I audible?
Yes, sir, you're audible.
Thank you. Thank you very much. Thank you very much for this opportunity. Many interesting things have been said. In fact, in my notes, a lot of keywords were already spoken. So I hope that what I say will have some relevance. I come from a scientific computing background. I do not have the background that like on the library sciences, etc., but more of a practitioner, you might say. So I'll just give you a perspective about the open source coming from the programming side, basically. So I was first exposed to the open source when Richard Stallman in MIT started opening up, like his code for entire community, and that was thought of as, what is this guy doing? I mean, how can you actually share a source code? In fact, many of us used to use that particular application. Today's word is application. Those days we used to call it code, and that has actually led to an enormous, developments in science and technology. Look at Linux, for example. It came from the same line of thought. So opening the, the source code coming from the programming side makes, the development process accelerate exponentially. And that we have seen that one. And the fear that, we may not be able to make a living by sharing source code is no longer there. And there are very clear revenue models which tell you how I can actually make money by using somebody else's source code, but there are very clear guidelines. In fact, the idea of a copyright is well known, but copyleft is what is used in the scientific software. And copyleft idea is actually evolved, naturally. It's not, like somebody's had, made a policy, etc. It's once again, a debate among the developers and how they actually these simple guidelines as to how to share it and what part of the code you can use it, redistribute it. The same thing, of course, now has propagated in the publications, right? The idea that if you take, for example, a scientific code, whether it is secure, for example, if it is actually proprietary, somebody can put something in there which can take away some of the data on your laptop or your processor or your even your mobile. It can be used to snoop on your devices if it is proprietary. But if it is made open source, it's just impossible. Nobody can actually put anything because it's open to all the eyes. Everybody's seeing it. The same thing, I think, extends to review process of a publication which is made open. It is wrong to think that only 2 or 3 experts can actually catch all the issues in a publication. There will also be biases, personal biases, which you cannot avoid. So making it open in the spirit of opening the source code of scientific code, it clearly has democratizes the review process. But then the question arises, like which review somebody comments, are appropriate, not appropriate. That is where I think you need technological interventions, basically, to kind of, like if you look at the Google page, it'll actually rank the pages, right? So those are all software technologies which can actually give you a way of categorizing the pages. Similarly, review process can also be assisted by these technologies in the future, and that will actually make it even better, in my opinion. And I think it was talked about judiciary also. Look at judiciary. Everything today is online. All their judgments are available completely. In fact, the government is looking for developing technologies to assist the judges to absorb all that, like information that is there. You talked about citation. It used to be that the lawyers, this thing, pick out a certain judgment from somewhere, I'll cite it and then win a case. Today, the information that is available on a mobile for a lawyer when he goes into a court of law is available to him or her ahead of the judges. It just comes instantaneously, right? But all this requires, like basically a burden on the computer scientists to develop robust technologies to absorb those knowledge and make it better, make it available. And then, of course, that will actually, open up several issues. I don't want to talk about that one. But what I find a problematic issue in India is, not being able to understand how to work in a collaborative model online. And this is my personal experience, and it comes from my background in scientific domain. Many of the excellent, like applications which are very, very complex are developed by people who haven't even seen each other, completely done online. There are procedures, they develop the protocol, they've developed the workflows, which makes it happen. But somehow that cultural change has not happened in our country, and that is something has to happen. There's no more fear of who gets the credit, etc., because many of those things have been ironed out in the at least software development community. So that much for the open source part of it. I just wanted to also make a few remarks on the data. I just want to give you one example, personal example again. We were working on the weather prediction code development, scientific domain, for which, of course, we need data. We need observation data from the rainfall data, moisture data, etc., all that is never necessary. And we used to never get the data for India. It was not available to us. As a scientific community want to develop this, good models for predicting the weather, etc., not available. In fact, we had a meeting with the Minister of Science and Technology, and then the people who would collect the data was the Indian Meteorological Department. The secretary of the department comes and says, we cannot share it because it is a security issue, believe it or not. This is about 15 years ago. Okay, right? And the science and technology minister laughed at them and said, what is a security issue? It's more of a cultural problem. It's more of a credit problem. It's more of like why I should share it when I have put in so much effort. Okay, right. It was more of that rather than giving a certain reason which was actually meaningless, in my opinion. So even then, even when a directive was given by the minister to share the data to the scientific community, it never happened. It never happened. That means basically the mechanisms of like credit sharing, credit giving are not in place. Okay, right. And that would be the fundamental reason why like that data was not being shared. Whereas if we wrote to NASA, they would actually send you data with the tapes and everything, manuals, all those things free, right? So that doesn't help, like, and if you take weather development, etc. In the when I want to develop a weather code, I need data that is pertaining to India. I need quality data. This is a very typical problem. And one issue on the raw data, I have a slightly different perspective. While I understand raw data per se is meaningless unless it's labeled, etc. But again, the labeling process, etc., for a large amount of data is an enormous, task. Once again, it should not be done by one or two people who gather the data. It has to be more of a community effort. It's a collaboration effort. In fact, if you look at the people who are doing a lot of artificial intelligence-based companies, labeling data itself is one major task. They hire people who sit and keep on labeling data. But this also needs to be a more of a community effort by the experts and train the people to how to label the data, etc. And again, one should adopt the online models which can make it happen. That's what I feel. Along, of course, with what the keynote speaker said, essentially, like, you also share the tools that are used for the processing the data. So somebody should be able to reproduce the results. I think that is extremely important. The tools and the codes, because even the codes and tools also get developed further and should also be open. So while like the as far as the data sharing or making it open concerned, I think its fundamental issue is who should share the data. I think public institutions must share the data. It's after all funded by the public, and they must share the data. Internally, they need to have the mechanism as to who should get the credit. I think again the keynote speaker said in a very different way, that he said opening data should be given credit for, and if you want to hide the data, you should actually give the reasons. And I think that's absolutely right. They're extremely important. Whereas on the private side, like, because they have made an investment and all that, and they can release the data after their own use, etc. Many of them actually still do, so there's no problem there. On the privacy of data side, there are, of course, typically medical data, etc. There are now many of the developments on the technology side where these things are being. In fact, I invited one of my colleague, Dr. Patra. He works on the private data privacy issues. If somebody has a question, he can answer that. So quite a bit of work is going on. On the data privacy issues. Okay. Again, these are all, of course, the technology issues. In fact, we also face the problem of COVID data. We keep doing the model development. We actually do a prediction every week and give it to the state government of Karnataka. And earlier, there used to be one portal where all the data was available for the COVID. But those people they were doing it's all voluntary. It was all voluntary, but they were not able to sustain it for a prolonged time. So it's not possible for somebody to keep doing it. So there has to be, like, some support that has to come to them. So I think that part is kind of missing in our country. How do like the citizens contribute to these efforts which are very voluntary in nature? That doesn't happen, in my opinion. That is something that we see that it happens in the West. It doesn't happen here, or at least much less, or at least I'm not aware of. Okay. It used to be available on one portal, but then those people are not able to sustain the effort. Obviously, when you cannot be doing on a voluntary basis forever, then we have to now actually sweep the data from various sources today before we run the model. In fact, my colleague Dr. Patra developed the entire process, sweep the data, and every week update the predictions. So those are the, so those are probably point at, like the cultural issues. And today when we talk about data science, like which actually generates knowledge out of data, without data we really cannot do anything. And if you look at the contribution of the data capture that we do compared to even China has gone way ahead in data capture. In fact, surpassed the US and all that. And that I think is an effort that one must do, keep it open. And we were actually trying to move the idea of, CSIR should actually become a scientific institution which will actually host all the scientific data. Again, those are not taken off. Because once again, the investment problems, infrastructure problems, where does the money come from? Those issues are still there. But I think it will happen over a period of time. It will happen over a period of time because people will begin to see the value of sharing the data, as well as the all the sources, etc. So those are my few comments. And thank you very much for the opportunity to be here. I was traveling, and therefore I'm glad that actually I could come to one place and sit and participate online at least. Thank you.
Thank you, Dr. Vidyadhar. Dr. Vidyadhar, with his background in computation, he spoke about sharing of source code. He elaborated on the process of development of, he's elaborated on the fact that the sharing makes the process of development faster. He talked about copyleft in comparison to copyright. And he talked about availability of open source in open. Better it's scooping because it is available for everybody and everybody is watching. He talked about the problem that scientists do not understand how to collaborate, and which is something that they must learn. Professor Vidyadhar mentioned that war should not be left to generals. It is a community who should make efforts to come around and make the data shareable. So it cannot be left to a couple of people, but it has to be community effort. And infrastructural issue is another thing that is touched about. So thanks a lot, Professor Vidyadhar. Now we'll have the house open and we invite question. You can ask your question. You can ask it to the entire panel or to a specific panelist. Yes, please.
Good morning to all. I am Ganesh Suraj from BIRC Mumbai. Sir, since 2012, Ministry of Science and Technology, Government of India is drafting a science technology innovation policy where open research data repository is a prominent component. My question to panelists is how this research data, coming from research laboratories, weather forecast and observatory, these economic trade data and hospital management data, how it may be implemented in future and can be used. Thank you, sir.
Well, in fact, the DST data sharing policy came in 2014. And of course, the report that you're mentioning in 2020. So the policies are there, but the implementation hasn't actually started. So InfluentNet has developed a repository for social sciences where only the data that is given by ASI and ISO is sitting. So even IISc, their own institution, they have about 20 odd institution, even their data is not there in the repository. They take, in fact, they fund social science research. That data generated through that source is not available. So there is a force need to be required. And you cannot say that there will be one national level data repository. There has to be multiple. And we cannot leave it to the government to start. Institutions like IITs, universities like central universities I think must come forward to take that initiatives. So, and this could be for their own university and this could be for the entire, they could be a subject specific data repositories and all. Would you have something to add, Pragya?
I think I'll add a little bit. Hello. Yeah.
Myself, Parthasarathi Mugavadai from Kollam University. I do fear this may be some novice questions, but I would first like to take the global take on this from Robin Rice and then from Pragya Madam. So, for example, let us try to understand that a particular journal paper is there and a related data set is there. So how these two can be individualized through the same DOI or something else identifier we need. Then suppose one particular paper may use many data sets and one data set may be the base for many publications. So how that N:2N relationship can be visualized at the end user part. And the third one is that, for example, you are all talking about dumping data in CSV format. Then until and unless it is available in JSON format and it is not supported through the REST API protocol, how can I selectively from my end can fetch data and use it selectively? So what is the global take on these three questions and what is the Indian community's thinking on these three?
Okay. So if I understand the first two parts of the question correctly, then I think then metadata is the answer, because certainly in our Edinburgh data share repository, we link to papers whenever possible through, and depending on the metadata schema you're using, we use the extended Dublin core as well, selected fields from Dublin core metadata initiative. And so, for example, we use, there's a set of metadata fields about relationships. So is related to, is referenced by, is cited by, this this paper references this data set. So if you use the standard metadata schema, you can identify those relationships, and they could even be picked up in a machine readable way without a human interpreting it. So, and in terms of the quality assurance of that, when our team accepts a new data set submission, we check to see if it's associated with a paper. Sometimes because the journal is requiring a DOI for the data set at the point of publication, the paper may only be in submission, it may not have been accepted yet, it may be forthcoming, not published yet. And this wasn't actually a policy I put in, but one of my curators was so enthusiastic that she kind of set up a procedure, and all the three of them do it, where they set Google alerts for when that paper is published, and then they go back and put in the DOI later. So I guess, for example, on Kevin's maturity model yesterday, that's a little bit of human extra energy to, so it's difficult to do that in an automated way, but yeah, we encourage people to cite their data sets and their publications, and their publications and their data sets, and if you use controlled standard metadata, then it should be able to differentiate those. And you can use the data, as I was saying yesterday, you can use the data set type for resource type, so that you know that it's a data set, not a paper, and it can be searched that way. As for the CSV files, maybe we want to hear from the science.
Robin, do you use DOI or something else for data sets? You're using DOI. Yeah, but then there is another handle services for data, which apparently is very costly. We try to use for IISc data repository, but it's very costly. Apparently, that kind of handle can recognize data at unit level. I haven't experimented with it, but those handles are available, which are specifically designed to handle data.
So I think your first two questions have been adequately answered, right? I mean to say, coming from a personal experience, so I'm a biologist and I used to work with larger scale genome data. So this was a very common kind of problem that we actually used to face, that we were working on multiple data sets and that would go into one publication, or like one single one would actually form set of different ones. So DOIs are actually kind of the common method that we used to work with. So because each data repository, public data repository would give us one DOI. And when we are actually mentioning within the publication, like this is the data set we are using, there is no restriction on that, right? Like we can tell like, okay, these are the following data sets that we have actually used. And even within NCBI system, so NCBI system is the one that I have actually mostly worked with. So they actually, they have a very elegant system in which they actually allow for multiple projects. Like you can deposit data within an umbrella of a single project, multiple data sets, or you can work around those things. So there are already models out there which actually address those questions. Now, coming to your third question, basically, I mean to say, I do not understand when you said the CSV format or the JSON format. When we are talking about research data, we are talking about multiple fields, and these fields have a variety of data. It's not just textual data. There's also media files. There are videos, there are audio sounds, and there are pictures. So we are talking about all kind of data. And so there is no such limitation. The only thing with these open data repositories where they are, people are supposed to be putting out their data is basically this data should adhere to the FAIR principles, which is findability, accessibility, interoperability, and reproducibility, right? Reusability, sorry. So, and to the second part of the question, which is Indian government's stance on it, it was very clear with the 5th draft STI policy. They have mentioned that public data should be put in public domain and they should adhere to FAIR principles. So obviously it kind of shows that for the Indian government that there is a will. Well, and if there is a will, they will find a way. So let's see.
I think most repositories support downloading of data in XLS format, in CVS, in JSON. So I suppose that, multiplicity of options are available. I hope your question is answered. Thank you.
We have a question from the online panelist.
Yes.
Sir, your contribution, particularly to make Indian science, open science, is significantly contributed. Before research data, you worked on thesis and dissertation, and before that you worked on Indian CAT. I feel that even mandatory policies didn't work. What is your experience regarding to achieve your target? What strategies worked, what didn't work? My second question is to Dr. Pragya. You are come from one of the oldest Indian Institute of Science, which is more than 100 years old. You mentioned that one of the issue for to make Indian, the data as an open science is a cultural issues. The diversity of Indian scientific communities is considered as one of the advantage globally. What kind of cultural issue your community have? I feel that your people are working in one of the best infrastructure. Okay, their promotion policy, their pay scale, what government funding, international funding, everything they have. I feel every researcher is not behind incentives. Can you elaborate on what type of incentive they are looking to make the data as open? These are the two questions to both of you, sir. Thank you.
In fact, I was going to answer that what Professor Dr. Chaube has mentioned is the answer, incentivize. When we started this Shodh Ganga, people were not very keen to deposit. Then we requested UGC, why don't you give money to them for digitizing back files of their thesis? And then, of course, anti-plagiarism package. So these two incentives brought people around to sign the MOUs. So I feel incentivization and regular follow-up does the wonder. But there has to be regular follow-up as well as incentivization. This is my experience. In CAT, again, there were incentives, but incentives were very limited for a very limited period, and very meager, which people were not very keen even to apply for. So incentives should be good and should be sizable. And of course, that there has to be regular follow-up. So this is my experience. And Pragya, a lot of questions to you.
Yeah, thank you so much for pointing that out. I mean to say, perhaps I was not very clear. So when I meant cultural issues, I meant cultural reluctance within the scientific community. And these cultural reluctance comes because there is no academic incentives. And yes, you are right. So when we are actually doing the survey, we found like a spectrum of people. So there are people who actually were happy to put out their data in public domain because it is it is in the favor of science. But you also have to see, like, everybody requires some sort of incentivization. I mean to say, nobody is going to put out their data, for example, prior to the publication, right? So that becomes one sort of incentivization, like, okay, we are publication is an incentive to academics. And so this is like a kind of currency thing we are talking about. So we need that kind of academic incentives. And I mean to say, I'm not so sure if I have answered adequately, but this is what I feel like. There's an entire spectrum, but like even scientists have all, like, with this open access thing and everything, we know with this commercial publishing, scientists have already been exploited a lot. So there should be incentivizations for actually, moving towards more open and better practices. At least in my opinion, that's what I feel. So.
Just to add that, earlier when we started this EPG Pathshala, not many people wanted to write modules for it because API. They write an article, they get good API. But if they write a module, there was no API. Now they've started giving API for writing e-module also. And people are coming forward now. So incentive does work. We have an online question.
Yeah. Dr. Patra, can you please unmute yourself? Thank you.
Yeah, thank you. This echo, okay. Yeah, I don't have question, but I just have some comments. Some time back, I had seen one cartoon which said, what is the difference between COVID and cold? The answer was like, if you get it is COVID, and if I get it is cold. Okay, similar to this, here the data, open data policy also is similar to this. If I collect data, it is closed, and then if you collect data, it should be made open. So that's the mindset that people have. So with that mindset, it is very, very difficult for us to bring out this concept of open data policy. And the major challenge that we have is the policy implementation, which is very, very slow. Like we are talking about data protection law, which has been there. We are hearing about it for last 3 years, and then talking about that it will be implemented soon and all, but nothing happens. It is still pending at the parliament level. There's another aspects which I think nobody is bringing out, is the concern about the quality of data. Sometime back, what happened is there was one institution, I don't know which is that, they had written to all the institutions saying that what kind of data you would like us to collect and provide it to you for your scientific research, because we are scientists, so we should be concentrating more on doing science rather than collecting data. Then I called a meeting of our scientists and then asked them. They said, no, we cannot believe their data, so we have to collect our own data and then use our data. We cannot do that. And once we collect our data, we don't want to share it with anybody also, because we need to do our research first. And I don't want somebody to use our data and publish even before we publish. So these are the challenges which are there, and only policies can bring in. The other aspect which Dr. Mudkavi pointed out is the privacy, where which I work in those areas. We are trying to bring out technologies, because policies, rules, laws, they're there, but then it's always difficult whether you will be able to implement it in a proper sense or not. But technology is something which can bring in lots of changes. How to provide data, like how to create a proper data repository. There we can talk about all policy, all kind of controls and other things. That's something that we are working on, especially on the privacy of the data, where people are talking about most of this healthcare data. And we are actually working with Aadhaar to see that how can we still make sense out of the Aadhaar data without really revealing the information about people, which is kind of a general concern that is there with everybody. So these are some of the comments that I thought I will make it and add to what Dr. Mudkavi said. Thank you.
Thank you. Any more questions?
Just a couple of things back on the incentives topic that I was thinking about. So in the UK, some of the funders have put in sort of teeth into their policies. I agree. Just saying that you must do this isn't necessarily effective. So some of the funders have done things around the money side, like, you know, you won't be able to apply again, or you won't receive the last 10% of your funding until the data is deposited. Some of those kinds of things can work. And one of the funders put it onto the institutions and said, you know, we expect the institutions to implement data management plans. They didn't want to do all the checking of the individual plans. So that's on the funder side. And on the institution side, or the repository provider side, there are things that help make the repository more desirable for the researchers, like along the lines of what we were hearing, that the scientists don't want to deposit the data until after the publication has been published. Well, the problem with that is once the publication is published, you're probably already into your next project and you're not thinking about that old data. So we can really use, and this works at our institution, is to use embargoes so that you deposit the data at the same time that you're submitting the paper. And it really helps if the journals require an identifier for the data set at that point. So they upload the data set and then we make sure that it's well documented, but then it's not open access. Only the landing page is available until they can set the date in the future. And we encourage them not to set a date longer than it takes for the publication to become available. So there are some incentives that make the researchers want to do this.
Thank you, Robin. I have a small incident to tell about how people are reluctant to share their data. This ASI and ISO data, which is now available in ICSR data repository, the request for data that came from daughter, I think it was granddaughter of Meghnad Saha. It came directly to the embassy, embassy passed it on to PMO, and then PMO passed it on to the department. You share the data. Now, their irony was that we don't share this data with our own scientists in India. How can we share it with outside? So then they decided we'll have a repository. The first opposition came from within the ministry that we don't want to do it because we have an income of more than 50 lakhs from this data. People buy that data sets on CDs and other media, so they don't want to lose. The irony is that Government of India spends hundreds of crores for gathering that data because there are surveys done, annual surveys done, gathering that data, huge task. So irony is that you spend 100 crores, 200 crores for gathering the data, and then just keep it with you just for 50 lakhs because you earn 50 lakhs. So finally they decided no more this thing, and we'll have it in open repository. So the incentive, or rather I would say the force to share it, came from outside India, from a granddaughter of Meghnad Saha, and the rest is, so there has to be some kind of a compulsion and policies and things to happen. So thanks a lot to everybody. I'd like to, at the end, thank my panelists, Dr. Robin, Dr. Chaube, and Professor Vidyadhar, who was with us. I hope he's still there. So thanks a lot, sir, for being with us and spending this morning. So I think it was a very fruitful session. A lot of question answer, very interactive. Thanks a lot for the participants for sharing, for asking question and for sharing their views. Thank you.
Thank you so
Thank you very much.
Thank
you very much.
Panelists and as well as the session keynote. We take this opportunity to felicitate our panelists. So on behalf of the Conclave organizers I request Dr. Arora sir to felicitate Ms. Robin Rice. Now I request sir to felicitate Dr. Pragya Chaube.